Welcome back to my YouTube channel. Today we will discuss a TIFR exam question. Question is given that n is greater than equal to 2. Then which of the following statement is true for every n cross n real matrix? Okay, which rank 1? Then option A say that there exists a matrix P and Q belongs to M and R. Okay, such that all entities of matrix PAQ are 1. Okay, and second option say that there exists an invertible matrix P, okay, such that PAP inverse is a diagonal matrix, okay, that is diagonalizable. A is okay. And third option say that A has a non-zero eigenvalues, and last option say that 111 belongs to Rn is an eigenvector of A. Okay, so now solution. First up we choose A equal to non-zero nilpotent matrix, that is 0 0 1 0 0 0 0 0 0. Okay, so we have A is not diagonalizable. Why? Because we know that a nilpotent matrix is diagonalizable if and only if it is zero matrix. Okay, and here is nilpotent matrix, but this is non-zero matrix, so A is not diagonalizable. So there does not exist any P belongs to M and R such that P inverse AP is diagonal matrix. Okay, or PAP inverse also diagonal matrix, not a diagonal matrix. There does not exist any invertible matrix P such that PAP inverse is diagonal matrix. If this is true, then A is called diagonalizable matrix. So already we given A is not diagonalizable matrix. So that is there does not exist any P invertible matrix such that PA inverse is diagonal matrix. Okay, so option number B is false. Okay, now similarly option number C is also false. Why? Because all eigenvalue of A, values of A are 0, because nilpotent matrix has all eigenvalues are 0. Okay, any nilpotent matrix eigenvalues are 0, we know that. Okay, so here option number C is say that A has non-zero eigenvalues, because here already given A has a 0 eigenvalues. This implies C option is also false. Now for D, option number D, we choose A equal to 1 1 1 0 0. Okay, and here also 0. Okay, so we have now 1 0 0 0 1 1. Okay, that is equal to 1 0. Okay, so this implies 1 0 0 0 1 1 lambda 1. Okay, here does not any lambda belongs to 0 comma 1 such that this is hold. So that means here 1 1 not a eigenvector. 1 1 transpose is not an eigenvector. Okay, because there does not exist any lambda belongs to 0 comma 1 such that this is hold. Okay, because here 1 0 0. Okay, So option number D also false. Okay, now answer of the question is 1. A is the answer. Okay, now proof. How to prove? Option number A. Now in general we prove. So first we define x equal to u transpose u. Okay, and we know that if rank of A matrix equal to 1, then A written as U V transpose. Okay, where U is the column matrix, okay, and V is also column matrix, and U and V non-zero column matrix. Okay, so now we define x equal to this and y equal to V transpose B. Okay, now so x transpose u, this equal to u transpose u whole transpose into u, that is equal to u transpose u into u, that is equal to 1. Okay, and similarly y transpose v, that is equal to v by v transpose v whole transpose into v. Okay, so this implies this is equal to also 1. Okay, now next, now set the matrix P equal to E x transpose. Okay, and Q equal to Y E transpose. Okay, where E equal to 1 transpose. Okay, so now PU, that is equal to, so PU this equal to E x transpose into U. Okay, and this equal to E into U by U transpose U whole transpose into U. So this equal to E. Okay, and this is 1 already we know, already we seen here. Okay, and also Q transpose B, that is equal to Y E transpose whole transpose into B, and this equal to also E by similarly process. Okay, from here we put this value and this calculate the value we given here E. Okay, now so now PAQ. Okay, PAQ, this is equal to PU V transpose into Q. Okay, putting the value of A, because A equal to U V transpose. Okay, so this implies PU. Okay, and here Q transpose B whole transpose. Okay, now putting the value of PU here E and QV, this E dot E transpose. Okay, here given E equal to 1 transpose. Okay, now put the value of E. So PAQ equal to 1 transpose into 1 okay, so this equal to 1 and here 1 okay, so this equal to, here we multiply here 1 okay, and also 1 1 1 dot dot 1 and this is equal to 1 dot 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 1. All entities are equal to 1. So hence the proof. We choose P as follows P as follows and X as follows, X and Y as follows. Then we given PQ such that PAQ equal to all entities equal to 1. So option number A is true. Okay, hence the proof.